You're welcome to today's class. Today we want to look at malloc function. In the last class, I taught you introduction to dynamic memory allocation. So, and I explained malloc, calloc, and realloc. So today I want to look at each of them. So today I'm going to look at malloc function. Now, malloc is malloc. This is malloc function. So this word malloc simply means memory memory allocation, right? So it is a utility call to the operating system to allocate space in the heap of the memory. I explained in the last class the logical part and the hardware part. So in the hardware part, what the operating system simply does is to create a process. And that process is like your soul, meaning a bundled memory and the state of that memory, right? That is simply what the process is. So the entire program I'm going to write now, you will see how it will be broken down and how that part of the heap will be used to allocate memory at runtime. So without wasting much time, let's get right into it. So the syntax for this malloc is simply malloc size underscore t, then size, right? This is how you are going to write it, because this size underscore t is what? Unsigned integer. The memory address can never be what? Negative value, right? It has to be unsigned. It cannot be negative. So if I put integer here directly as the size, then it will throw me and it will be a problem. So let's write a C code to explain malloc proper. Okay. So here I will say include st standard input stdio.h. So this will allow us to call our print function. All right. Then I will also include another library. Include stdlibrary.h. So this will allow us access the utility, which is what? The malloc function, the calloc function, and the realloc function. So this will allow us access it. Now I will call my main int main. Now inside it, I told you when you create a memory in the heap, you can only access that memory through a pointer. So first, let's declare a pointer. So I will say int a pointer numbers. So at this stage, memory has not been allocated. Now I'm going to create malloc using this pointer. So I'm going to use this pointer to get the address from the malloc. So I will say numbers, right? Then, because it is an integer, and malloc will return a void pointer, so I need to typecast it to an integer. So I will say int. So I'll typecast int asterisk, right? Then malloc. Then in bracket, I will say, now I want to allocate memory for 3 integers. That's what I want to do. So the first thing I'll do is 3 times, right? Size of, so I'm calling the size of operator int, because this will allow me to be able to access the size of integer from any of the computer system. So some computer system will allocate 2 bytes, while some will allocate 4 bytes. So with this, I'm safe. It allows the program to move from one system to another. So I'm going to close this. So this is me calling my malloc function to go to the operating system to request for what? For memory size for 3 integers. And integer is 4 bytes. So 4 times 3. That will be what? 12 bytes allocated side by side. Now, it's going to collect the address of the first integer. So I have something like this. 1, 2. So this is what? 4 bytes. So this is another 4 bytes. So this is another 4 bytes. Right? So total of 12 of what? 12 bytes. Then this has an address, this has an address, this has an address. So the address of this one is what is going to return to what? To this pointer. It will store it in this pointer. Okay. Now I have done this. But I don't know. I have to test to be very sure that the memory was allocated, because if it was not allocated and I try to assign a value, then it will try an error. So I must check, because sometimes the operating system will get to the heap and the heap will be full, right? So it cannot access memory. So it was born in a manger, not because it didn't have money to live in a very nice place, but the inn was full, right? So the operating system can go and check, and it will see that memory um, location in the heap, or the heap is full, and to throw you an error. So I need to check if actually memory was allocated. So I will say if numbers equals to, this is equals to operator, equals to null, then come back and print f memory allocation failed, right? Slash n. Okay, so I'll check that. Then I'll say return 1. So that means there's an error. I'll close this here. So this is me checking to be sure that memory was allocated. Now, if memory was allocated, it will skip this place. So if numbers is not equals to null, meaning it's not equals to null, so it will skip this one. Then I can now assign values. So because this is like an array, I've given an array of 3 integers. So I'll say numbers, right? So the first one, which is what? 0 index, 1 and 2. So 0, here I'm assigning 10 to it. Then numbers, 1, I'm assigning 20 to it. Then numbers, 2, I'm assigning 30 to it. Okay, so this is me. I have done this. Now, I want to print out these values on the screen. So what am I going to do? I will call my for loop. I will use my for loop. Um, I will use my for loop. I don't know, you might still be seeing this, but it will not be able to contain my for loop script. So let me bring it here. So what should be here, right, is what I'm writing here. So I will say for int I equals to 0, I less than 3, I plus plus. I've taught you for loop extensively. So inside this my for loop, I will say print so here I can still write, I can write here print f, right, after malloc, that is after memory allocation slash n. So after memory allocation, then I want to print out the values. So print f, here I will say percentage d slash n, comma, numbers, right, I. Then I will close my for loop. Okay, now my program is not done. Because of space, I'm just managing. So I will come here again. So what should be here, right? what should be under this place is what I'm going to write here. After printing this out, I will say free numbers, free numbers. Then I will set numbers to null, null. Then I will say return 0. That is the end of my program. Then this curly bracket, I will close it here, right? So this is my program. Um, so what happened is this is my program, followed by this part, then followed by this part. So this is the first part, right? It's just because of the board. That's why I have to manage the board. So let's quickly explain this. Now, the memory. So you have this. So this is the stack. This is the stack memory. So this main will be copied into this. So our main, the frame will be created here. Then it will go in, and then it will create this pointer. So this pointer will be created in the frame. So this pointer, which is what numbers, will be created in the frame. Then it will come to this place and call this malloc. So the operating system will go to the heap memory, which I explained to you. So the operating system will go to the heap and create a memory size of what? 12 bytes. That is 4 bytes for each. Multiply by 3, that is 12. Then this place will check if that 12 byte was actually created. If numbers is equals to null, then it will print memory allocation field. Else, it will come here. Then it will assign 10 to the first location, assign 20 to the second location, assign 30 to the third location. Then it will print out after malloc on the screen, right? Then it will go to the next line, and it will use this my for loop to access each of them. So for I equals to 0, which is what? The first index. So you're having something like this. So 0, 1, 2. So for this first index, it will go in and it will print out whatever is inside, which is what? 10. Then it will increment I to what? To 1. Then 1 less than 3, that is true. It will come in and it will print out what is inside. That's why you're having I here. So it will become 1. So numbers 1, which is this one, it will print out 20. So it will print out 10. Because I am putting this /n, it will print out 20 and it will print out 30. Then it will increment this one to 3, right? 3 less than 3, that is not true. Then it will come out and it will get to this place, free numbers. So it's going to free this pointer, right, from that memory address. Now, the moment it does that, the pointer will become a dangling pointer. So if another person accesses that same address and then put a different value there, that pointer can still access that value. This is how hackers can access your computer. So the best thing to do is to set the pointers to what? To null, meaning you forgive and then set boundaries, right? So it's very important. Once that is done, you return to the operating system, and then the program is done. So this free, meaning you free the heap memory. So this is how malloc works. So let's go to code blocks. Let me demonstrate this for you to see. All right, so this is our code blocks, and this is the code I showed you on the screen, on the board for malloc. So I'm just going to execute this code script for you to see, and the output will be 10, 20, 30, right? So let's do that. So you see, this is the output. After malloc, 10, 20, 30. Okay, so now let me remove this so that it will show that I did not initialize it. Then you will see what the output will be, garbage values. So let's execute this script again. So you see, garbage values. Now, if I run it again, still garbage values, but another value. If I run it again, still garbage values. But in the case of calloc, the values will be 0. So in the next class, I will demonstrate calloc for you to see. So malloc will allocate memory, but it will not initialize it. So when you query it without initialization, you will only see garbage values in it. So that is what I want to show you in this class. So till we see in the next class. Bye-bye.